we are solving the fifth question, that is t square minus 15. This question also not in the standard form, that is ax square plus bx plus c, because the middle term, the term with the t is not there. So for getting factors, we can apply the different method instead of the splitting the middle term method. Okay, but when we are comparing the coefficient, this should be written in the standard form. Okay, so first we are going to get the factors. Okay, that is t square minus 15. Okay, t square minus 15 can be factorized with any of the identities. Okay, so this is of the form, can we use a square minus b square form? Okay, even if here the second term b is not a square number, in order to use a square minus b square, okay, it would be better if we have two square numbers, you can easily write it as t whole square minus, if it comes 25, okay, 5 square. Or if non-square number comes, okay, what happened? You have to keep that number under square root. Doesn't matter. What I said is t square minus root 15 whole square. See children, this root sign and square term get cancelled. So root that is 15 comes. So we got equivalent expression as in the LHS, in the RHS also. Okay. So children, this is very important. Others, see, if we have t square minus 9, this can be written as t square minus 3 square, since 9 is a square number. Understood? But if we have a non-perfect square number, okay, what to do? You just keep that given number under square root and get square. Okay, that means that square and square root get cancelled. So there is no change, it comes in RHS and LHS. Okay, so this is the way you can apply this a square minus b square form. Okay, so children, so here in place of a is t and b, that is root 15. So a square minus b square is a plus b into a minus b. Okay, so we can apply that identity in order to get the factors of this. That means that is a in place of a t plus root 15 into t minus root 15. Okay, that is a plus b into a minus b. Okay, in order to get, why we are factorizing? To get 0. Okay, that means p of t can be equated to 0. P of t equal to 0. To get the zeros of p of t, equate p of t into 0. Okay, so that means this each factor can be equated to 0. That means t plus root 15 equal to 0. So we will have t is equal to minus root 15. Okay, the other side t minus root 15 equal to 0. That means t is equal to plus root 15. So this is equal to beta and this is equal to alpha. This point is clear, children? Okay, so t square minus 15 can be written as t square minus root 15 whole square. In order to use a square minus b square is equal to a plus b into a minus b. Okay, so we are going to verify. Okay, that is alpha plus beta is equal to minus b by a. So children, we can before verification, children, you have to compare the given equation with its general form. Okay, so a is equal to t square, coefficient of t square, that is 1. B, the middle term is not there. That means this is actually p of t is t square plus 0t minus 15. Okay, so here b equal to 0 and c is equal to negative 50. Understood? That point is clear, children? Here the middle term is not there. So you can include that term by making its coefficient 0. That is 0x. Okay, here because of t, 0t. Okay, so here comes alpha plus beta. Alpha is minus root 15 plus beta is plus root 15 equal to, what is it? minus of b, b itself 0, so 0 by 1 equal to 0. Here children, minus root 15 plus root 15 also 0. So both side balanced, 0 equal to 0. So alpha plus beta is equal to minus b by a. Okay, when you take the ratio, that is minus b by a, we got 0, and when we add two zeros, that is alpha plus beta, that case also we got 0. Okay, so hence verified. So one more, that is alpha beta product of zeros is equal to c by a. This is the condition. Let us check. Alpha beta, that is minus root 15 into root 15. Beta is positive root 15. This is equal to c by a. What is c? Minus 15 divided by 1. Let us see. See, if you just close this negative sign. What is root 15 into root 15? Root x into root x is x itself. Okay, here x can be any number. Okay, so root x into root x is simply x. So root 15 into root 15 is 15. And this negative sign. Okay, so negative 15. Understood children? Okay, root x into root x is x itself. So root 15 into root 15 is minus 15. Okay, and here minus 15 by 1 is minus 15. So LHS equal to RHS, that is alpha into beta is equal to c by a. Hence verified. Next we are solving the sixth problem, that is the last problem. Okay, that is 3x square minus x minus 4. Okay, see children, this is in the standard form, ax square plus bx plus c. Okay, so we can apply the splitting the middle term. Okay, and since the variable in x, okay, so p of x. So to get the 0, p of x is equal to 0. Okay, so 3x square minus x minus 4 equated to 0. We are using splitting the middle term. Okay, by comparing, you can write a is equal to 3, b is equal to minus 1, c is equal to minus 4. Since it is splitting the middle term method, we are applying, get the product equal to AC, that is 3 into negative 4, that is negative 12. Okay, now sum, that is the coefficient of x minus 1. What can be the factors of 12? The product. Okay, that is factors of 12, 1, 12, 2 and 6. But here we can use only 4 and 3. Their product also 12. But when we should get the sum 1. So 3 and 4. When you subtract, you will get 1. Okay, so the factors of 12 equal to, that is 3 and 4. Now children, here the product is negative. So what is here children? One of the factor must be negative. And that negative sign goes to the biggest number. Why? Because if sum also negative, the biggest factor carries the negative sign. Okay. So then only when you take the difference, the negative sign will remain. Okay. So negative 4 plus 3 is negative 1. That is what we needed. Understood? So we are going to split this middle term. Okay, so 3x first term and last term no change, minus 4x plus 3x minus 4 equal to 0. So I am going to group these into two groups, and from this you can take 3 and 4. Nothing is common. Okay, so in the constant place, that is coefficients, but in variables x square and x is common. So I am taking x outside. So 3x square by x, divide each term with the number outside. So 3x minus 4. See the second group children, the 3x minus 4 you can keep as it is by taking 1 outside. So 3x minus 4 equal to 0. See children, if you taken the common factor from the first group and see the factor, if the second group is same as that, you can take 1 from that and keep that remaining terms in the bracket. So you can easily take this 3x minus 1 and 3x minus 1 as common in the next step. 3x minus 4 and 3x is remaining in the first term, and this plus sign and 3x minus 4 divided by 3x minus 4, you will have 1. So now we have two factors of the given polynomial, 3x square minus x minus 4. Okay, so in order to get alpha and beta, you can equate each factors into 0. Okay, so children, 3x minus 4 equal to 0 means 3x equated to 4, minus 4 become plus 4. So from this you will get x is equal to 4 by 3, and this is alpha. And the second factor, x also can be equated to 0, that is x is equal to minus 1. Okay, this is because of factor theorem, children. If x minus a is a factor, okay, x is equal to a is a 0. Okay, that is why we can equate this into 0, each factor. Okay, x minus a equated to 0. Okay, so we have now beta as minus 1, alpha and beta. Now we are going to verify. Okay, that is alpha plus beta equal to minus b by a. So here 4 by 3 plus minus 1, beta minus 1 equal to minus b by a. B itself minus 1, so its negative is 1 divided by 3. So 1 by 3. Let us see what is in LHS. So since they are unlike, you can just cross multiply. So 4 plus minus 3 by 3, that is 4 plus minus 3 is 1 by 3. So 1 by 3 is equal to 1 by 3. Understood, children? So hence we verified. Okay, so we are moving to the next set, that is second question of exercise 2.2. So we are continuing with exercise 2.2, that is question number 2, that is we have to form quadratic polynomial. We are given sum and product of the zeros. See, find the quadratic polynomial each with the given numbers as sum and product of its zeros respectively. That means 1 by 4 respectively, that is what first one is the sum and minus 1 is the product. That is alpha plus beta is the sum of the zero, that is the first number, that is 1 by 4, and product of zeros, that is product of 0 is the second one, that is alpha beta is equal to minus 1. This quadratic polynomial can be easily formed by using two methods. One is the form I already given, that is x square minus alpha plus beta into x plus alpha beta. That is the equation, x square minus alpha plus beta into x plus alpha beta. Okay, or you can write this alpha plus beta equal to minus b by a, right? We have the general formula ax square plus bx plus c, isn't it? So here alpha plus beta is equal to minus b by what that we have already shown, that this is equal to 1 by 4, that is given. That means in place of b, okay, that is here minus b is the numerator, so 1. So b is equal to minus 1. Here a equal to 4, isn't it? Denominator is 4. What is alpha beta? Product, that is given as minus 1, and we know that is c by a, that is minus 1. Understood? See children, this minus 1 can be written as minus 1 divided by 1. But that means in place of a, 1 comes if we are simply taking c as minus 1. Okay, but we have already got a as 4. So how this can be converted into 4 equivalent fraction? So 1 into 4, 4, and minus 1 into 4, 4. No problem at all. So you will be getting minus 4 by 4. So a, this case a also same as 4, but c is equal to negative 4, this numerator. Idea is clear, children? When minus 1 comes, since a is 4, you just multiply, make it an equivalent fraction by multiplying, dividing with both the fraction with the 4. Okay, so minus 4 by 4. Okay, multiply numerator and denominator with the 4. Okay, so now we have a, b and c. What is the general form of a quadratic polynomial? Ax square. A means 4x square plus bx. B is negative 1, that is negative x. Okay, plus c. C is negative 4. This is a quadratic polynomial. Okay, or you can use this also, that is x square minus alpha plus beta into x plus alpha beta. You can just substitute, and that case also you will get to the answer. Idea is clear, children? For the second question, see children, alpha plus beta, that is root 2, that is minus b by a. What is the general form? Ax square plus bx plus c. This is the general form of a quadratic polynomial. Okay, this is so this can be written as root 2 can be written because it is, we should have denominator, numerator and denominator. Okay, so here minus b by a, so root 2 by 1. So in place of minus b, root 2 implies b is equal to minus root 2. Okay, this divide with minus 1, so minus root 2. So see, a is equal to denominator is, we should express this in the form of a by b. So denominator is a, that is 1. So we need c because we should get the constant. So alpha beta is equal to 1 by 3, that is equal to c by a. Children, here alpha beta equal to 1 by 3, that is equal to c by a. So in place of a is 3, that is a is 3. But here root 2 by 1, that is minus b by a is 1. How this can be solved? Because we should get in place of a 3. So make equivalent fraction, multiply this with 3 into 1, this also 3. Multiply numerator and denominator with the same number, then only you will get equivalent fraction. Okay, that means you will have now b is equal to minus b is equal to root 3 root 2. So this will be minus 3 root 2 and a is equal to 1. Sorry, c is equal to, a is equal to 3 and c is equal to the numerator, that is 1. That step is clear, children? That is, since here a is equal to 3, but in the first ratio minus b by a we got as 1 because root 2 simply given. Root can be written as root 2 by 1. Okay, but we have seen that a must be 3. For that I just multiplied this numerator with 3. So you can easily make this denominator, that is a as 3. So in that case b become minus 3 root 2. Here a is equal to 3, c is equal to 1. Now we can form the equation. Okay, that is a, that is 3x square. Okay, b is minus 3 root 2x plus 1. It's very simple. Or you can apply this here also, x square minus alpha plus beta into x plus alpha beta. That case also you can easily get the quadratic polynomial. Now we are moving to the third problem. That is 0 is alpha plus beta is given, that is alpha plus beta, that is 0, this is minus b by a. Alpha beta equal to root 5, that is c by a. Okay, see children, since alpha beta equal to root 5, that means you have to make this in fractional form. So you have to definitely write here a as 1. But here, in order to get 0, you can divide this 0 with any number other than 0. But since here a must be 1, you have to divide this here with 1. Okay, now after finalizing the values, you can write the coefficients. That is, here a is equal to 1, b is equal to minus b in place of that 0, that is b is 0. 0 has no change, sign. So c is equal to in place of c here root 5. So the general form is ax square plus bx plus c. Understood? That is ax square means x square. Okay, and 0, coefficient of b 0 means no constant, second term, middle term, plus root 5. This is the quadratic polynomial for sum as 0, alpha plus beta 0 and alpha beta equal to root 5. Now we are solving the fourth question. Here we have given the sum of the 0 as 1 and product also 1. Okay, we have to find out the quadratic polynomial whose sum of 0 is 1 and the product is alpha beta equal to 1. Okay, so what is alpha plus beta, sum of the 0? Alpha plus beta is equal to minus b by a. And what is given? This minus b by a is given as 1. Okay, see children, always write the sum, the given sum of the 0 in the fractional form. If it is a whole number, that is 1 can be written as 1 by 1. Okay, so in place of b, minus b equal to 1, that means b is equal to minus 1. Okay, a is equal to 1. In place of a, denominator is 1. Now, alpha beta, product of zeros, alpha beta, that is equal to c by a. And what is given? That also 1. So, 1 can be written in the form 1 by 1. Okay, so in place of c, the numerator, that is c is equal to 1 and a is 1. Okay, so now we have the coefficients a, b and c. And what is the general form of a quadratic polynomial? Ax square plus bx plus c. Okay, so in place of a, 1, so x square, in place of b, minus 1, so minus x, and c is plus 1. This is the required quadratic polynomial. Idea is clear children? Okay, just substitute alpha plus beta as minus b by a. Okay, and the fifth question, we have given minus 1 by 4 as sum of the zeros. See, being it is quadratic, alpha plus beta can be equated to minus b by a, and that is given as minus 1 by 4. Okay, and alpha beta, product of 0 is given as 1 by 4. Okay, 1 by 4. This is equal to c by a. C by a. Okay, now we can write down a, b, c. Okay, if minus b equal to minus 1, that means b is equal to 1. Minus get cancelled from both sides. Okay, and what can be a? A is equal to 4. Here also a is equal to 4. So we can fix a as 4. Now c comes. We need c, the constant term. Here the numerator is 1. So that is equal to c. So c is equal to 1. Now we have a, b and c. So that we can easily write down ax square plus bx plus c, and that is equal to, what is a? A is 4x square. Okay, b is plus 1, so plus x. Coefficient, if it is 1, we are simply writing its variable, and constant term is 1. So this is the required quadratic polynomial if sum of the 0 is minus 1 by 4 and its product is 1 by 4. Now the last problem, that is, if alpha plus beta equal to 4 minus b by a, that is equal to 4, and alpha beta c by a, that is equal to 1. Last problem. Now we are going to write down a, b and c. Okay, so children, in place here being both are the constant term, that is single term. Okay, you can write this in the fractional form 4 by 1, and here also 1 by 1. Okay, so minus b numerator, so 4 implies b is equal to minus 4. Okay, and a is equal to 1, here also a is equal to 1. So b is equal, c is equal to numerator, that is a constant term. So we are going to write the required quadratic polynomial by substituting these values in the general form. So ax square, that is x square, a is 1, coefficient is 1, b is minus 4, minus 4x, and constant term is plus 1. So this is the quadratic polynomial if sum of the 0 is 4 and the product of 0 is 1. So this is all about exercise 2.2. Thank you children. Thank you for watching and supporting my channel. Thank you all.